All right, folks, welcome back for part two. Was there a shorter way to determine his speed at the bottom? Yes. All right, so let's go back to this idea that his kinetic energy at the bottom equals his potential energy at the top. And I want to just point out that that comes from the simplification of this equation up here, where at the top he didn't have any kinetic energy. So we can sort of just cross off this part here, because before he fell down there was no kinetic energy, and at the bottom he had no potential energy. And so that's where we were able to come up with this claim that kinetic energy at the bottom equals potential energy at the top, because these are the only two terms left in that. And this was before would be the same thing as saying top, and after would be the same as saying bottom. All right, because these were both 0. PE and bottom, PE at the bottom and KE at the top. Okay, so just want to clarify that before we move on, because we're going to use that very same equation here. So in the end, we're saying the potential energy that the skater starts with at the top will equal the kinetic energy that they have at the bottom. And now we're going to put in our equation for what potential energy is. It's the mass times gravitational acceleration times the height. And the kinetic energy at the bottom is equal to 1/2 times the mass times the velocity squared. Now, we can use algebra to simplify this. So the first thing that we can see is that we can divide both sides by the mass. And that makes mass cancel out of the equation on both sides. So what we're left with is GH equals 1/2 times V squared. Now we can do another math step. We can multiply both sides by 2, and that allows 1/2 times 2 to cancel out. Because remember that 1/2 times 2 would be the same as like 1/2 times 2 over 1, which is equal to 2 over 2, which is equal to 1. So what we have for our equation now is 2GH equals V squared. And then we can do a last algebra step, which is take the square root of V squared to get V, and that means we have to square root the other side as well. So now what we end up with is V equals the square root of 2GH. Let's plug in the numbers that we have. We know that G is 9.8 meters per second square. We know that height is 5 meters. So when we multiply this out, 2 times 5 is 10. 10 times 9.8 is 98. So we're going to get the square root of 98. And this time I'll use the units in there just to be a little more complete. So we have meters times meters, which will give us meters square. And then we have seconds on the bottom. And when we do the square root of 98, we're going to get the same thing that we got before. Just to verify, 98 square root is 9.8 or 9.9. So we have 9.9. And when we do the square root of meters square, we get meters. When we do the square root of, I'll show you what I mean by that. When we do the, here we go. When we do the, so here's meters square. When we do the square root of meters square, we get meters. When we do the square root of seconds square, we get seconds. Okay, so you might say, well, Mr. Geller, that didn't look like it was that much less work. but it kept us from having to calculate the kinetic energy. And actually, it gave us a whole new equation here, which is this equation that I'll highlight in blue with a star. This equation is saying that as long as we know the height that something is falling, and we know the gravitational acceleration, which is how fast objects get faster when they're falling, then we can predict what the velocity will be at the bottom. And this equation does not have mass, so it shows us that the mass doesn't actually affect the speed at the bottom. And it's really saying that there's only two things that are going to affect it, h and g. Keep in mind, this is saying that there's no friction. If there is friction, then this just becomes the maximum possible speed at the bottom. Okay, so example 2 here. A skater with a mass of blank starts from a height of blank. How much speed will she have at the bottom of the ramp? We're going to do this one together in class. So thank you for doing this pre-work to get through the theory part of it. And tomorrow we'll test the theory using simulation data in Energy Skater, and also using some real data of roller coasters. And we'll connect that back to our results from a roller coaster investigation. Okay, thank you so much for tuning in. Have a great day.